Here we want to rationalize the denominator of each of these radical expressions, and we're going to assume that the variables are positive whenever they appear. Most of these are numerical values, except for the last one. So what we want to do then is rewrite each expression so that no radical appears in the denominator. So the first one we have 2 over the square root of 3. Again, we're going to use some properties of fractions where you're allowed to multiply the numerator and denominator by the same value as long as you don't multiply it by 0. So I want to make this 3 under this radical a perfect square. So the best way to do that is to multiply by the square root of 3. And that's legal as long as I multiply the numerator by the same thing. Because all I'm doing is multiplying by the square root of 3 over the square root of 3, which is 1. So this would give me then, on the numerator, 2 times the square root of 3 would give me 2 square root of 3. That's a simplified form. We don't want approximations unless it tells you. So we're going to give exact answers. The square root of 3 times the square root of 3 is 9. Square root of 9, and the square root of 9 is 3. That's the simplified form for that one. Now for the second one, we got the square root of 3 over the square root of 8. A couple of ways to do this. The best thing to do is say, well, the 8, I can make it into 16. That's a perfect square if I multiply it by the square root of 2. And the square root of 2 up here. This would equal 2. Then, again, we'll multiply by 1 here. So square root of 3 times the square root of 2 is the square root of 6. And the square root of 8, both under the radical, so you just multiply them. 8 times 2. Square root of 8 times the square root of 2 is square root of 16. Square root of 16 is 4. So I get the final answer for this one, square root of 6 over 4. Okay, and for the third one here, a little bit different here, because now here we have a difference at 2 terms, and one is a radical. Sometimes they both could be radicals. So here what I'm going to use is the fact that whenever I have the difference and the sum out of the same 2 terms and multiply, it just gives you the difference of the squares. So this comes out to a squared minus b squared. Multiply this out, a times a is a squared, minus b times b is minus b squared. And this product here is minus ab, and this product over here is minus ab plus ab. That cancels. I get the difference of the squares. So that's how we're going to rationalize this one here. So we're going to have the square root of 3 over 5 minus the square root of 2. And we're going to multiply the numerator and denominator by the conjugate. That's the same 2 terms except the opposite sign. So this would be 5 plus the square root of 2. And then same in the numerator, 5 minus, or 5 plus rather, the square root of 2. And let's see, in the denominator, by what we just mentioned, I got the difference in the sum of the same 2 terms. That's the square, the difference of the square. So 5 squared is 25 minus, and then radical 2 squared, that's radical 2 times radical 2. That's the square root of 4, which is 2. This gives me a 2 here. So this would give me then, again, these I just leave it in product form here, or factored form. This will give me the square root of 3 times 5 plus the square root of 2. And then the denominator, I have 25 minus 2, that's 23. So for number 3, I get radical 3 multiplied by 5 plus the square root of 2 over 23. And number 4 is similar, again, 5. Similar to number 3, got 2 plus 3 radical 5 in the denominator, so we're going to multiply by the conjugate there. So this will be 2 minus the square root of 5, and that's over 2 plus 3 square root of 5. In order to eliminate the radical here, again, we have to multiply by the conjugate. And in this case, it would be, this is a plus, so we use the minus. If this were a minus, we would use the plus. So this would be 2 minus 3 square root of 5. Multiply the numerator by the same thing, 2 minus 3 radical 5. The denominator is an easy one because it's just multiplying the two conjugates here. 2 plus 3 radical 5 and 2 minus 3 radical 5. So it's just the square, difference of the squares. First term squared is 4, and then it's minus, and 3 radical 5 squared, that'll give me 9, and then the square of radical 5, or radical 5 times radical 5 is 5, so this would be 9 times 5, it's 45. This could be a negative 41, 4 minus 45. Now these are the two in the numerator. I got 2 minus 3 radical 5 and 2 minus square root of 5. Okay, so 2 minus the square root of 5. I have that one here at the bottom. And then this one over here, 2 minus 3 radical 5. It's on top here. So let's do it this way. We can go 2 times 2, that's 4. Right there. And then over here, this product, negative, negative, that'll be a plus. And then that's 3 here. And then radical 5 times radical 5, that's the square root of 25 is 5. So this could be 5 times 3, this would be 15. And then just cross multiply here. This would be minus 2 radical 5. And then this way, minus 6 radical 5. Then the 4 and the 15 is going to be 19. And the minus 2 here, radical 5, and the minus 6, that's minus 8 radical 5. So then this goes in the numerator, so this would be 19 minus 8 radical 5. And that could be your answer. Normally we don't like the negative in the bottom, so let's multiply the numerator and denominator by negative 1. Denominator will be a positive 41 then. And the numerator becomes a minus 19, multiplying by a negative. And then the minus 8 becomes a plus 8, square root of 5. So minus 19 plus 8 times the square root of 5 over a positive 41. That's the simplified answer for number 4. Here's this one. Number 5 is just a single cube root in the denominator. So again, how do we make this a perfect cube? That is the radicand 2. Well, we can multiply this by what? Cube root. 4 times 2 is 8. And 8 is a perfect cube. So let's put here a 4. And of course, multiply the numerator also by that. And of course, cube root of 8, that's 2. That's your answer. So that's 5 times the cube root of 4 all over 2. Now let's look at the next one. Number 6. Got a radical again, a difference of 2 radicals here. So again, obviously we're going to multiply by the conjugate of this. So here's what we're going to have. In the numerator, it's the square root of x plus h plus the square root of x minus h. And then we write out the denominator, square root of x plus h minus the square root of x minus h. Remember, variables, we're assuming everything could be positive. So now, to eliminate the radical expression from the denominator, we multiply it by the conjugate. So this is going to be the sum. This is difference here. Let's make it a sum. So it's the square root of x plus h. And then it's going to be a plus here, the opposite of what we have here, plus the square root of x minus h. Multiply the numerator by the same thing, square root x plus h plus the square root of x minus h. Denominator is fairly easy. We have the difference and the sum of the same two terms. It's always the square of the first one minus the square of the second one. So this quantity squared is x plus h. Squaring that radical expression simply eliminates the radical here, and then it's a minus, and then we put this in parentheses, the square of this one. So this would be, again, just eliminates the radical. This would be x minus h. So then we got x plus h, and minus the x there gives me this, and minus that gives me a plus. So the x minus x cancels, and I got h, and h is 2. So in the denominator, I'm going to have 2h. So now, in the numerator, what are we going to have in the numerator? We're multiplying this out. So let's do it this way. We know if I put just like I did earlier, put it under here with this one here. This and this multiply each other. This and this multiply each other. And then this multiplies this, and the other one multiplies the other one. They cross multiply. So let's do it this way. Square root of x plus h plus the square root of x minus h. This is the first one. And then underneath I put the square root of x plus h multiplying by this one, be plus the square root of x minus h. Okay, so here we go. This product right here just gives me x plus h. Square root of x plus h times the square root of x plus h just gives me x plus h. These two multiply out to give me a plus. This multiplied in the square root, so it comes out to x minus h squared under the radical, so that's the square root. That just gives me x minus h. Now we cross multiply this way, and cross multiply this way. So that's just going to give me what? Square root of x plus h times the square root of x minus h, and the same thing over here. So this is just going to be 2, the square root of x plus h times x minus h, but that's just going to give me x squared under the radical, be the square root of x squared minus h squared. Okay, these multiply to give me x minus h, and the same thing over here. X plus h times x minus h is x squared minus h squared. And it gives me two of those. One this way and one this way. And then what else do we have here? The h and the minus h, that cancels out. So what do we have left? We have an x and an x. So let's put that up here. That's 2x. And then we have this quantity here. So we got a plus 2 square root of x squared minus h squared. And notice these have a factor of 2. So I could factor out a factor of 2 from the numerator, and then I have a factor of 2 in the denominator. So those divide out. So I'm going to have left in the numerator an x plus the square root of x squared minus h squared. Again, the 2 cancels in the denominator also, so this gives me an h here. So the final simplified answer is x plus the square root of x squared minus h squared over h. That's your final answer. Thanks for watching. We'll see you next time.